All right, this one is number 6 from section 1.3. Let's read the instructions. It says determine if B is a linear combination of A1, A2, and A3. So we're supposed to decide if B is a linear combination of the A's. All right. And notice that that's really equivalent to saying, do there exist constants x1, x2, and x3 that satisfy this equation? Is that true for constants x1, x2, and x3? If that's true, then B is a linear combination of A1, A2, and A3, just by definition of linear combination. But I want you to see that that's really equivalent to deciding whether or not a system of 3 equations is consistent or inconsistent. Notice that if I replace the A1 with its vector, 1, 0, 1, and do the same thing for A2 and A3, I end up with a system of 3 equations and 3 variables. Because we said in the last example that something like this can be changed into a system of 3 equations. I guess I can write it out just one time real fast. This is really equivalent to this system. So if that system has a solution, x1, x2, x3, that means that B is a linear combination of the A's. So we really just have to try to solve that system for x1, x2, and x3. Just decide whether a solution exists. So let's do that. And I guess I'll do it by constructing my augmented matrix first, and then we'll try to put it in reduced echelon form if we can. All right. So there is the augmented matrix. All right. So let's do this column by column. That's supposed to be a 0. So negative R1 plus R3. Negative this plus that is 0. 4 plus 3 is 7. Negative 12 plus 10 is negative 2. Okay. Now, looks like the first column is finished. Let's go on to the second column. I would divide the second row by 3. But it looks like we want to change that 4 to a 0. So I would do that by multiplying the second row by 4 and adding it to the first row. So 4 times 3 is 12, minus 4 is 8. And then 4 times negative 1 is negative 4, plus 12 is 8, looks like. So let's work on the third column. So change that 7 to a 1. By dividing the third row by 7. Okay. All right. So now let's change that 3 to a 0. And I can do that by multiplying the third row by negative 3 and adding it to the second row. And I'm going to use a calculator for the last part. Looks like negative 1/7 is what I get there. And I'm going to go ahead and do this in one step. I'm going to change the 8 to a 0 too by multiplying the third row by negative 8 and adding it to the first row. So that'll make that a 0. using a calculator here too, but it looks like 72 sevens. But the point is, it looks like we are able to solve that system because we were able to put this in reduced echelon form. You can see there's two. You can see that there's a solution. There's actually one unique solution. But really, you just need at least one solution. So it looks like the answer is yes. B is a linear combination of the A's.